it's one slide further, it doesn't matter. I always like to start with this slide. You are what you eat. Many people will believe that, and they see that the left part of the slide, if you eat too much, fat will grow, and that will have consequences for your metabolism. What is less well recognized is that actually the same applies for your immune system. As you're sitting here, you have about 80% of your immune cells circling around in your intestinal tract. And it's one of the most metabolic active organ of your whole body. It's more active than any other tissue in your body. And it also applies that if you do not eat well, it has consequences for the reactivity of your immune system. That is a bit the things that I'm actually focused on. It has been painfully illustrated during the Corona crisis that if you do not eat well, that will have consequences also for your disease development. About 50% of the people that actually died were male above 50, with a body mass index above 35. So that painfully has illustrated that it's very important to also study the impact of nutrition on your immune system. It has been estimated that about 80% of all the diseases that you encounter will come in either via your mouth or via your lungs. It's actually not so long that we do recognize that the gastrointestinal immune system is the largest immunological organ of the human body. I've given immunological lectures for about 25 years already, but only since 2015 I could find textbooks on immunity where also the mucosal immune system of the gastrointestinal tract was being discussed. So it's quite recent for younger people, probably 10 years. It's a very long time, but for people like me, 10 years is a very short period of my life. And it's quite amazing that only as of this period we start to recognize that everything you have in your intestine is immunological related and not only a digestive plant for the food that you consume. Every individual here in the audience, if you take the intestine and you throw them along this path, will have 7 to 10 meters of immune active tissue. And it contains villi and crypts, and if you all take them apart and you cover just a piece of land, you will see that there's about half a soccer field full of immune active tissue. It's really enormous. There's also gender bias, sorry guys, but our immune system in the intestine is not so active as that of females. Also, females have a somewhat larger mucosal immune system. They are more strong in their responses. But the bright side of this is that the male flu really exists. We do suffer a little bit more as males. So everything in the intestine is always ready to kill. But they also have a unique system by which they can induce tolerance, and that's very hardly needed because in our intestine we have 100 trillion bacteria, friends that we really need for production of all kinds of molecules that we cannot produce ourselves, like vitamins, so-called short-chain fatty acids, and we'll come back to that a little bit later. And these are quite important for our metabolism, for immunity, but also, for example, for our mental health. That's something that I actually recently came into. I don't have any scientific papers on this field yet, but a lot of things that are happening in the intestine have an immediate impact on how you feel. Where I mainly focus on is actually how the immune system does recognize what we do eat. And that's being done by a special family of receptors in the intestine, so-called pattern recognition receptors. So the immune system, the mucosal immune system, is extremely complicated, and still every few months we can discover a new cell type that is being evolved in this orchestra of events. But basically, if you look to the luminal side here's normally where the food is, you will see that all these immune cells and epithelial cells have one thing in common, is that they do sense what's going on with those pattern recognition receptors. And how it works a bit is that, for example, if a salmonella-like, flagellant-like molecule comes in, then this can bind, for example, to toll-like receptor 5, and that gives downstream then a pro-inflammatory response. But for example, if it's a commensal bacteria like a lactobacilli, then it will bind to 2,6, and that combination of 2,6 that might help in inducing more tolerogenic responses. So nothing actually in terms of immune responses against those bacteria will happen then. Now what we have done in the past 10 years, we have built a sort of technology platform, which I will show in my next slide, in which we try to recognize which molecules in our food are responsible for positive or negative effects. And I'm going to give you a spoiler already. It's very chemistry dependent what I'm going to show you this coming 25 minutes. So what we have is sort of a technology platform where we have a huge amount of different cell types in which we can sort of see what the different molecules in our diet can do. And we also have worked a lot with probiotic species, but I will concentrate today mainly on fructans and dietary fibers. And that we can do with quite some molecules, a couple of hundreds. But along this project, we want to show that this kind of molecule can also have a positive impact on mostly prevention of disease. And we have quite some animal models, either ourselves, or we work with groups that have those models. That can be done by a limited number of molecules. And at the end, a few of those molecules will actually enter into the human study, which is extremely expensive. So I cannot do a lot of these kind of studies, but I've done a few. And today I want to take you to one of the advances that we have actually done with fructans, and I've been working with my friends in front from Mexico with a different type of fructans, but I want to show you today what these fructans actually can do, and Cynthia will tell a little bit more about other things. But I want to start actually with something else, just to illustrate you how this platform can help in understanding how certain molecules work. At a certain moment, we came to a project where we found in this technology platform that certain pectins were actually doing something very positive. And we found during our adventure that they could bind to so-called toll-like receptor 2 ligand, toll-like receptor 2. So what normally happens if you get an immune stimuli, which can be an intracellular component, for example, if you undergo an injury, is that this immune stimuli will bind to toll-like receptor 2. As such, that doesn't really matter. But if this fuses with toll-like receptor 1, then you get downstream an activation and release of pro-inflammatory cytokines like IL-1, IL-6, IL-8, and then inflammation will start. What we found is that some of these pectins actually were able to bind exactly to the ligand binding site of toll-like receptor 2. And as a consequence of that, toll-like receptor 1 could not fuse anymore with 2. And we didn't see any pro-inflammatory responses anymore. Well, more regulatory responses were still intact. So this was really a great finding, and now we probably have, what the heck, why is this important? Well, we also knew from the things that we did that this, for example, is quite important in signaling, for example, the side effects of well-known chemotherapy agents, doxorubicin. Doxorubicin also here is given as one of the most common chemotherapeutic agents with breast cancer, with stomach cancer. What has a side effect is that it's not only killing the cancer cells, but also healthy cells. Healthy cells will then explode and release molecules like shock proteins, different types of danger associated molecular preference that will bind to this toll-like receptor 1 signal. So we were like, okay, this is very important in this disease and the side effects, and very often in the Netherlands, we have to stop it therapy because of these side effects, and patients eventually will die, and it also falls into a lot of children actually. So we were like, can pectin be helpful in that? So what we did was giving doxorubicin to mice, and we combined it either with pectin or just with vehicle, a little bit of C-line. When we just gave doxorubicin, we saw a huge amount of damage, which was much less, not zero, it's still biology, so you always have some damage, but it was about 5% of the cells that were being damaged. And as you can see in this picture, the small intestine, the structure was still quite intact. Really saw still villi, cells were viable, so it went quite well. Now, just not to immediately start buying pectins, there are so many different types. There's just a specific type, especially the low DM ones, because these low DM ones, they can bind to the toll-like receptor 1. That actually do the job. So if you want to know which type of pectin it is, you can look up this paper and find it. We also did a lot of work together with Gabriel. Gabriel has been very helpful in also understanding how these molecules bind. When I started with this work, I tried to publish this in pretty high impact journals, but they always said, yeah, just prove that it really binds. And actually, Gabriel is very good in molecular docking and has shown us that certain bacterial structures really will bind to these ligand bindings like OH2 fusion cannot occur. And yeah, since then we really started to understand how this whole process works. So now back to the fructans. I also have been involved a lot in improving together with some companies infant formulas. Normally, if breastfeed to children, milk as such contains a lot of so-called human milk oligosaccharides. Human milk oligosaccharides are involved in the maturation of the immune system, but also the development of the gut microbiota. When breastfeeding is not an option, and in Europe it's about 75% of females, they cannot exclusively give breast milk for several reasons. I don't know how it is here in Mexico, but I guess it's a little bit the same. We give cow milk and then supplement that cow milk with certain dietary fibers, and fructans actually is one of them, to try to mimic what normally the human milk oligosaccharides do. So we want to improve the colonization of the intestine and also immune development and mental health. So at a certain moment we came into a project where some companies, producers of infants, asked us, what can you do to support immune development in the first couple of months? An issue that they had is that if mother milk was not an option, they saw a higher frequency of infections in the first 3 months after birth. And what normally happens, all of us actually here, when you're born, we have a relatively high amount of so-called T helper immune cells. And they are needed to produce tolerance because you cannot attack as a baby your own mother. You are actually pretty allergenic, so you're not the same. So you are normally programmed actually to protect cells of your mother. So we're born like this with a huge amount of T helper 2 cells, but we also need those so-called T helper 1 cells, which are usually quite specific against pathogens. And normally within 3 months, if you are normally on breastfeeding, you will develop a response in which you will have more T helper 1 cells to fight fungi or kind of pathogens, and a little bit of T helper 2 cells that are responsible for inducing tolerance. This transition we have studied for many, many years, and we found something very remarkable when we were working with invalids. And it was for us the first proof that if you consume certain dietary fibers, it's not so much the quantity, but the type of fiber that you consume to have a positive outcome. We found that in this transition, and we also know the background now a bit, is that long-chain ingredients was strongly effective in supporting this response. We really saw that in a very short period of time, there were a huge amount of T helper 1 cells and much less T helper 2 cells. There was much less of short-chain ingredients, which were at that moment, this is about 8 years ago, actually the products on the market. That changed actually because of our work, and I'm pretty proud of that. I also had to explain to them why this actually happened. That's I'm going to show you a couple of slides. Everything I'm going to tell right now is about chicory inulins, which is a relatively simple molecule compared to, for example, the graminin-like inulins that are being used here for infant formula. Cynthia was speaking about Gabriel as well. And there are a few others, Levon-like inulins that are also very common, where we have also worked on. But this is one where I want to show you all the advances that we went through and have been able to show that it has really very positive effects on health when you give it the right combination of issues. So when we found these positive effects, and that was about 8 years ago, everybody was like, yeah, but that's not the effect on gut microbiota. Basically, it's true, a lot of things can be explained by impact on gut microbiota, but not all the things. I'm really now advocating a lot that many things that we see are not so much due to effects on gut microbiota, but not direct effects. So what we did, we gave instead of incubations with human microbiota, but also mice, we compared the impact of short-chain and long-chain ingredients, and actually found that both can support the development of the gut microbiota, supported the development of huge amounts of production of short-chain fatty acids. But basically, there were no differences between short and long-chain. So then we were like, might there also be a direct effects? So is it possible that just like the bacteria said, or one of the first studies, is it possible that also these aliens might they actually signal via pattern recognition? So what we did, we used our technology platform to do a huge amount of cells in which we had transfected the expression of certain pattern recognition receptors, like receptor 2. And what we found actually is that the short chain neurons were much less effective in stimulating receptor 2 than long chain, which really needed a huge amount of short chain neurons to get a response with very low amounts of long chain. And also here, we have worked with Udan, with Gabriel. We were able to show actually how they were able to stimulate, and it was a little bit different than what we saw with packets bound to different sites, and that work has also been published. So when we found this part, we were like, okay, this is quite special, and at that moment everybody was completely focused on microbiota, and we were like, okay, we showed the first time that some dietary molecules like directly bind to root receptors. Unfortunately, when we sent it in, that's also always what we do. They made our lives so miserable that they said, well, it can be this, it can be that, and if you want to publish this, you have to show that this indeed is also happening in vivo. So we went back to the drawing table and we're like, yeah, how can we prove in the absence of gut microbiota that this indeed has a direct effect on the immune system? So at that moment, I decided to do a very big investment. We did set up a germ-free mouse colony, so mice that don't have any gut microbiota are completely sterile in those huge sterile rooms. And we were able actually to give these animals for a long period of time either short chain units and more long chain units. And then we did a lot of things, pieces of the small design just to see what actually was happening. And to our huge surprise, we saw that there were 78 unique genes, mostly actually more in the metabolism regulated by short chain units, while the long chain units regulated with 76 unique genes, which were mostly in the immune networks. And the overlap was quite minimal. So when I saw this, I was like, okay, let's also then reconstitute actually the design with real gut microbiota to see what's happening then, where also in these cases the short and the long chain we're doing something different. And when we did, we still found this huge separation of differences, despite the minimal chemical differences. But what was even more surprising is that we only found an overlap of 4 genes. These 4 genes, I don't know whether they're experts in the room, are all 4 at each molecules that are being expressed on epithelial cells to allow colonization of gut microbiota. And well, we now have a personal theory about why many of those molecules that currently are in the formula will work. And that is because we have seen many times that whatever you give, in all the different physics molecules, but for immature epithelial cells, they support the expression of these molecules like FOXP2 with the growth hormone. And if this is being expressed in high amounts, the bacteria and what is binds to the epithelial cells. It also supports the binding of small fermental bacteria, which is known to support the development of very specific immune responses. But also there are instrumental prevention of the diffusion of pathogens like Salmonella typhimurium. So this we now see as the central reason why most of the molecules that currently are in infant formulas do work. We think this is the mechanism. So they support the high expression of these molecules, support the faster colonization of the intestine, and which support the development of metabolism and the brain health as well. So, but then we were able to prove in our technology platform that short chain and long chain were doing different things. But then we were like, how can we actually prove in healthy individuals that this indeed is having an immune supporting effect? And just think about it, you're healthy, and you want to give something where you show that somebody is even more healthy. That's quite complicated. So we were thinking first about all kind of vaccination protocol, because that is a natural way of challenging human beings or you give a shot of, for example, flu vaccine. You give something here that supports immune development. If you give something that's further support, that would be better. But most of the vaccination protocols that are currently available, certainly for that of influenza, is so extremely efficacious. About 97% respond to that. So it's very difficult with a lower number of people to prove that it really works. Then I found that we are doing something in the lab, which actually can help us. Before a student actually can come to work in our hospital, they have to receive a hepatitis B vaccination. And if something is very efficacious, it is the hepatitis B vaccination. You need about 2 to 3 shots before you're fully protected. So the development non-response is quite high. So I asked a few of my students to volunteer and asked them actually to take immunities for a period of 14 days, double-blind crossover design. So they got either short-chain immunities or long-chain immunities. And our central hypothesis was that long-chain immunities actually should be one that supports blood responses, so anti-pathogen responses. And it worked. So what we saw is that when we gave this vaccination, and we asked the students on a daily basis what they did, but not actually much was happening. Well, with the long chains, we found a higher and faster development of antibody titers, but also a higher number of responders. So we did that also one time, and again, we found that indeed these long chain inhibitors have an immune supporting effect. So this was very positive, but these kind of molecules are doing more. How am I doing time-wise? Yeah, okay, because I started a little bit later, so it's more fine. Also, we do a lot of work on barrier function. We are living in a time where stress has become quite normal. We take a lot of painkillers, which impact on the availability of this time. We are encountering, for example, also food particles, spicy food actually. So it's feeding with spicy food when I'm here, but that also has an impact on the permeability of the intestinal wall. And what happens quite often in your intestine is very lightly bound, molecules above 300 kg up to pounds. If this barrier is being broken, all kind of large molecular structures can come in. And what sometimes happens is that you can develop immunity. So normally, only small molecules should pass the individual barrier. But you might add somewhat large protein structure. In my thumb, for example, is antigen that is, for example, also present on insulin-producing cells. It might happen that the immune system wrongly recognizes this food particle and also the thumb as something foreign. And by coincidence, it's actually also is attacking the insulin-producing cell. And you can type 1 diabetes. So, something I didn't share yet in this lecture is that we did much more. We knew that inulins, especially again, these long chain inulins, had an impact on many different other things than just on the immune system. We knew it was supporting good bacteria like bacteria and some bacillus. We found in vitro that it also could actually reinforce the tight junctions between these different cells by which it actually was binding more strongly. And also it actually was able to support the production of antimicrobial proteins like alpha-fetacins, which is seen as the natural antibiotics and kill particles. So from a previous life, I knew that in certain mouse types, like NME mice that will develop autoimmune diabetes, a leaky gut was being involved in the pathogenesis of the disease. So normally after weaning with these mice, when they go to solid food, they have a phase in which the barrier of the epithelial cells will be a little bit broken. And we know that then antigens may flow in and actually support the development of the autoimmune process. So I knew that from the previous life, and I was like, let's try long chain immunities actually to work with this model as well. So what we did after weaning, we gave these animals long chain immunities identified by biology. And we found that after a period of follow-up of 25 weeks, in controls, about 40% of developed diabetes. And only one that was on the long chain inulin diet became diabetic. The rest remained almost the rest of the life. So of course we went also further to see what could have happened. And what we found when we looked into the pancreas is that this is an island, like anti-pancreatic islands, that was completely infiltrated with also the immune cells, while we only saw a few of those immune cells in the animals with long chains. This actually were found later on regulatory cells. But there was even more. I'm not saying that this was the only thing that was happening. We also found that in the group with long chain immunity, especially in the sebum, there was an upregulation of the production of all kinds of short-chain fatty acids, which are known to be involved in generating T regulatory cells and support hormones production. Something else we found is that we found an enhancement when we were analyzing the gut microbiota in the ratio of therapeutic to bacteriosis, and especially when this ratio is quite high, then you will have a higher likeliness of having a more heterogenic phenotype. So that was also actually good. So this was all about chicken immunities. Actually, other immunities do work as well. We have worked recently, and there's quite some papers upcoming right now on so-called evil type factors. They are very common in nature. But also extremely interesting are the family of factors that are coming from agave, which is the tequila and here in formula. And Cynthia actually is the one who has done all the work on that, so I will stay completely away from it. Cynthia has been working here for far longer, but she's teaching for 2 years and 2 years in Groningen in my group. And she graduated together with me and Gabriel. She will have the honor to get the friends to work with she's done in this area. So I hope in the past, I'm really doing quite well time-wise. I hope I have shown you that, and I think that's very important to mention because in many food advices it's still like if you just consume more dietary fibers, you will be more healthy. It's really not true. So I hope I have convinced you that there's more chemistry that determines whether you will have health effects than just eating more. It doesn't make sense to just eat more. You need specific ones for specific types of supportive responses. There are also quite some families we found from the work that we've done that actually don't do anything. So you can consume them, but they're just fill out and they have no real health benefits. Also, I hope that I've convinced you because we are living in a time that all my colleagues want to explain everything on immunity by impact on the gut microbiota, and I feel this is quite exaggerated. So I just have examples of the fructose that actually do work directly on the immune system. Because we have seen that in this case it's more important than effects on the gut microbiota. I don't want to say it's not doing anything, but it is a bit exaggerated how people are now working with the effect on the gut microbiota. And I would like to end with this one. I could never have done all this work without the support of Cynthia, Gabriel. They are real friends. I believe that if we want to come far, we have to work together. And yeah, they can do things that I cannot do the other way around. So I feel that is really very strong. So thank you very much for your attention.
Thank you very much, Paul. Any questions?
Doctor, you mentioned that there are molecules or immunities that will prevent the dimerization of TLR receptors 1 and 2, which are cell surface receptors. So my question is, there are molecules that will prevent the activation of endosomal or cytoplasmatic TLR receptors?
Good question. I know some pathways can do that via specific pathways, but I really have to jump into it, which one it can be. I cannot really say.
Any TLR receptors, endosomal TLR receptors is fine. Yeah, my question.
Now we have proved, we have seen that some peptides actually will go intracellularly and actually will inhibit like 8 and 9. Okay, so yeah, so if the proof for that is quite difficult. So we don't know whether it's not a fact or whether it's really happening. So there's an ongoing debate within our group. So we have to use blockers and that kind of things to really prove its binding to intra-endosomal peptide recognitions. I actually believe it does.
Thank you. Well, I have one question. Do you think that we can use carbohydrates now for some diseases or something applied to the human health?
Yes, absolutely. Yeah, I think that many of them. So, yeah, in fact, fructans are being used to prevent allergies already. Yeah? So that's the real proof already that it works. Since that we're using these kind of fructans in the formula, the allergies really went tremendously down. So it was a huge impact. So that's the real like proof already. But I'm also involved in a few trials where we want to give certain peptides to people that are suffering from IBD. When you are in the process of IBD, I would recommend to different people. Sometimes you see that Biología that are responsible for fermentation is clearly reflected. But if you give it in a healthy phase, you see that the healthy phase actually extends. So you can prolong the healthy phase by this.
And talking about the boosting you saw with the vaccines, do you think are the fructans, directly the fructans, or maybe the combined action of fructans plus bacteria?
Combined probiotics,
Symbiotics, yeah. We have done a few of those trials and it doesn't work. And they do nowadays a lot more also in the lifestyle, where they get a combination of specific probiotics that have beneficial effects and dietary requirements that support equalization and impact. It seems to work. Yeah.
I was wondering, what's the rationale that you found to kill small Celular section versus NLRs or even RLRs, the RIG-I like receptors? But we know that, for instance, non-2, for instance, or the NLR family is a major predisposition marker for colitis and IBD. So it could be another ground to look at integrating honestly.
Yeah. So we did just a couple of C-type vectors, but we have cell lines for lots. They don't seem to work to do a lot of that. No inhibition and no activation. So yeah, we have never seen any impact of that. But for example, galaxy 3, we have done quite some work there. We see a huge amount of effects. Yeah. And it's known for galaxy oligosaccharides that they actually bind to different types of C-type vectors. For example, this design that kind of molecules. Yeah.
Any other question? No? Thank you very much, Paul.
You're welcome.
Okay. The speaker actually is also our friend, Dr. Pedro Gutiérrez Castellón. He's head of the International Scientific Council for Probiotics and founder of the World Association for Probiotics in Pediatrics. He has an H index of 32, around 3,600 citations of his papers, around 76 papers in 5 journals, and as I told you, he's a very good friend of ours.
Thank you very much, Gabriel. It's a real pleasure to be here. In fact, I feel really humbled to be here in this excellent Congress because this is a cell biological Congress, and I am a clinician, I am a pediatrician, so it's my honor to be here. First of all, I would like to say thanks to the organizers, especially to my friend, Gabriel Lopez, and the lecture that I will share with you is related with microbiota, gut and respiratory microbiota, focus on the role of probiotics in terms of risk reduction for respiratory clinical condition. As Gabriel mentioned, I don't have any conflict of interests, and most of the evidence that I will present and that we have been assembling together with Gabriel and Cynthia is endorsement by the International Scientific Council for Probiotics and the World Association for Probiotic, Prebiotic, and Postbiotic Pediatrics. The first part of my talk, my dear friend Paul already helped me a lot because he started to talk about the different interaction about the microbiota with the different cells in the gut system. And every day that we analyze the evidence that we have that we produce is related with microbiota, and I mean not only gut microbiota, I mean respiratory one, skin, eye, whatever, we immediately identify new evidence that is building and building and building. And one important consideration is related with the dynamics of the microbiota in the different parts of the gut system. You can immediately identify that it's not the same amount of microbiota that we have on the mouth, or that we have on the short intestine or wherever, but at the same time, if you look at the right side of the panel, you can immediately notice what are the different mechanisms, what are the different interactions that microbiota have 1,000 of different activities, not only related with immunity, I mean with metabolism, ileal salts, production, vitamins, etc. At the end of the day, one of the most important physiological interactions is related to how about the microbiota play an important role in terms of immunity, in terms of what are the synergistic effects. I mean, bacterium, viral, bacteriophages, and microbiome. And independently of the different activities that Paul mentioned some moments about, related, for example, with the interaction of the dendritic cell and how they promote the maturation of the humoral and cellular immunity, there are another important relationships, for example, what are the role of specific species of bacterium, such as example Bacteroidetes, and what are the intimate relationship with different immune cells activities. But this relationship not only occurs on the gut system, in a resembling manner, in a mirror manner. You can observe here in this paper that were published very recently, what are the interaction and what are the evidence with the respiratory tract, I mean the upper and the lower respiratory tract. And what are the effects of the different integrated parts of the microbiome to produce different natural peptides, different natural antimicrobial substances, such as lactamine, 3-fatty acid, etc. And at the same time, through the different interactions, for example, with different kinds of interferons, that they balance the activity of different opportunistic pathogens, or on the downstream also you can immediately notice the relationship and synergistic activity for example, the macrophages, alveolar macrophages, and the production of different syncletic oxide, and what are the important relationships. Some moments about Paul talks about different interactions. What about the role of the microbiota present in the abdominal gut? And also in terms of metabolomics, what are the role and importance of short-chain fatty acid and interact with distant and remote tissues such as the respiratory tract. In this new concept that in this moment we have about interaction only cases, the brain, gut, microbiome immenses, but also the gut, microbiome lung abscess, and how the behavior of the different parts of microbiome to the intestine and the interaction with the metabolism that produce some activities in terms of the longamine, the interaction with phagocytosis, the absonization of the different viruses or bacteria into the lung tissues and so on and so that. And this is a very, very amazing new avenue that in this moment are producing. Because not only when we talk about infection, when we talk about immunity and infection control or risk reduction, but also you immediately notice in this very, very recent paper that were published on cancer cells that inside the humoral tissue we have been identifying the different patterns of microbiome or virome and what are the role of the microbiota that is included in the humoral tissues and oncogenic tissues and what will be the effect that they produce with the different therapeutic interventions, not only chemotherapy, but also related with some kind of biotherapeutic actions, and how the interaction and synergistic effect with the microbiome is present into the oncogenic tissues, they can modulate the effect that the chemio or biotherapeutic can have. Based on those rationale now, not only talking about microbiome, what is the role then about the probiotics trying to move on a relational point of view? What, in terms of immunity, in terms of integration, in terms of bacterial translocation, and also related with leaky gut, that is a very important phenomenon. As you can identify on the right side of the panel, the interaction between the different parts of microbiome to enhance the overexpression of different enzymes such as clonine, such as occludin, etc., that are intimately related to the phenomenon of tachyon that is very, very important when we talk about modulating immune reduction, and also when we talk about inflammation, and when we talk about specifically strains of probiotics, for example here, Limoxila, Lactobacillus at the top of the slide, how through the interaction with the histamine receptor 2, they modulate the different cascade of inflammation related to that. With this rationale, and moving into the clinical arena now, I will present to you a couple of different evidence that we produced based on the previous evidence that I had already shown to you, and based on previous randomized clinical control trial, that it was assembled to demonstrate what would be the safety and the efficacy of the different specific dose response of different strain of probiotics to modulate the behavior of different respiratory conditions. Around 13, 14 years ago, the first randomized clinical control trial that were published demonstrated that when some kids receive some specific dose of a specific probiotic, here for example Lactobacillus rhamnosus in a dose of 10 to 10 CFU, they reduce the frequency, the severity, and the duration of different respiratory conditions, and at the same time, the gastrointestinal symptoms were significantly reduced. Some years later, in another very elegant randomized clinical control trial, one friend of mine, Dr. Steve Weissman of Israel, also showed us that the different effect can be produced with a specific strain of probiotic. Here, it's being compared to different strain of probiotic, B-lactic, BB12, opposite with Limosil, Lactobacillus rhododendron, and they demonstrate a different effect, different magnitude and synergistic effect in terms of reduction of diarrhea, respiratory condition, etc. And in 2014, this was the first randomized clinical control trial that Gabriel Lopez and our group of research at the National Pediatric Institute produced. It was a randomized clinical control trial where something to demonstrate what would be the safety and the efficacy of this specific strain of probiotic Limosil, Lactobacillus rhododendron DSM 7938 in a dose of 10 to 8, 1 dose per day. In kids who were attending daycare center in terms of how they will reduce the frequency and the severity of respiratory condition. This design was attractive because first of all, we administrate the totally healthy children who attended daycare center for 12 weeks and a specific dose daily for this kind of probiotics, and then after they finish the 12 weeks of intervention, we continue observing for another 12 weeks to look how the immunoenhancing effect they will modify when we stop to administer this kind of probiotics in two different branches, one with the active branch and the second with a placebo trying to demonstrate what could be the effect. We include around 240 different kids, and at the end of the day, after the 12 weeks of observation and follow-up, we demonstrated a significant reduction, and you can see the top, the point we demonstrated that we have a significant difference effect compared around 93 different episodes opposite to 200 with a significant difference in that way. And also that the duration of the respiratory symptoms of the kids in yellow persistent probiotics were significantly reduced not only during the weeks that the kids received the probiotic, but also during the follow-up with a non-intervention demonstrating that even the probiotic disappeared almost immediately that you stop to give the probiotic to the kids. The immunoenhancing effect persists during the next week of observation. At the same time, not only the duration of the episode, but also the severity of the episode were significantly reduced, and for sure, the day when fever and the school absenteeism were significantly reduced. And when we go for a cost-effectiveness analysis, we demonstrated too, not also the safety, not also the clinical efficacy, but also at the same time the cost-effectiveness intervention that this kind of probiotic can help for the population when giving these public health approaches. Trying to assemble on a very elegant analysis of the evidence, not only our paper, but also previous papers who were published by SD or Rina and Justina in 2012. We assembled this systematic review with meta-analysis in 2016 that demonstrated that in a very exhaustive systematic analysis, a positive effect that we can observe here, how the line separates significantly from the non-effect line. And since statistical point of view, you also immediately notice that at the end of the day, at least this specific evidence for one specific single strain of probiotic, the clinical effect on that way. Some years later, in 2019, we moved together with one colleague of mine from Chile, Dr. Silvia Cruzeta, and the group of colleagues in a network meta-analysis, trying to demonstrate the next step in terms of what a specific strain of probiotics can help us to reduce significantly the frequency, the severity of respiratory condition. And based on this network analysis, first of all, we analyze the quality of the evidence for sure, trying to include the biostatistical approach for this network analysis. Only the different papers have a very strong quality of evidence. And then in this figure, which is on the right side of the panel, you see the sucra value. We compare at the same time the exhaustive clinical effect of the evidence, and at the same time the clinical impact of the different interventions. At the end of the day, together with Reuterin and rhamnosus, we demonstrate that Bifidobacterium lactis B12 were the most strong strain of probiotic that can help to reduce the risk for respiratory conditions. Later on, and based on previous evidence that demonstrate some different effect of the different strain that you observe here, in terms of immunology, there are not the same activity that produce Reuterin DSM-7938, and you can observe how they modulate the suppression and the activity of interleukin A opposite to pyrogen, for example, with Reuterin PTA 6475 and so on and so that. And based on the second paper to demonstrate not also with this cytokine, but also with another one such as TNF-alpha or interleukin-6, what could be the synergistic effect to combine not only DSM-7938 but also another strain of the same family on Lactobacillus rurae. And we published this paper very, very recently in 2021. It was a second randomized clinical control trial that Gabriel Lopez and the group of colleagues and me. Assembly this randomized clinical control trial was a proof of concept with 70 different kids who attended the center combining Reuterin DSM-7938 and Reuterin ATCC-PTA 5278. And you can observe here we have around 25 kids who were allocated to receive the intervention, and around 25 kids were allocated to the control group with some similar patterns as a clinical point of view. And since a relational point of view, we not only measure clinical parameters, we also measure different cytokines, immunoglobulin A, and inclusive we measure soluble PLR2, PLR4, to demonstrate what will be the potential mode of action, that how they can reduce the fever, how they can reduce the short throat, another clinical manifestation, and the group of kids. Since an epidemiological point of view, you can observe here a combining different etiology, not only viruses, rhinovirus, adenovirus, influenza A, etc., and also another types of viruses such as coronavirus, or for short, not SARS-CoV-2, and a combination in some cases about not only viruses but also bacteria. And at the end of the day, the primary outcome in this randomized clinical control trial was the effect of this combination of probiotic to modulate some clinical parameters who are, since a parent point of view, the most important, such as fever and short throat. And you can notice immediately that starting on the day 2 of this field, you observe a significantly most important reduction with a significant statistical differences for the kids who receive this combination of probiotic opposite to what occurred with the controls. The same occurred with this evaluation, the severity by flat score. You also observe that on the day 3 of the starting of the clinical picture, the children who receive this combination of probiotic reduces significantly the short throat, and they maintain the rest of the days. And also, at the same time, we observe the duration of the symptom were significantly reduced, together with significant reduction of rhinorrhea, and also the episode of nasal congestion. And also, since a relational point of view, when we analyze the different biomarkers, as I already mentioned to you, we demonstrate a significant effect. This is the blue before the training, in orange after the 15 days of training. We demonstrate a significant reduction of the kids who receive the probiotic with an increase on the level of RNA and modulation of the soluble receptor, toll-like receptor 4 in this randomized control trial. And finally, just to give you a couple of examples about the translational of the evidence into the clinical arena. Very recently, again, with the participation of Gabriel Lopez and another Mexican colleagues in the general hospital that we have been collaborating very recently, we demonstrated a combination of different probiotics. Here is plantarum and pediococcus acidilaticin. What could be the potential effect in adults with COVID, active COVID, mild and moderate COVID? How the use of a specific combination of probiotic can modulate the evolution of this type of subjects. We included a trial around 150 different subjects who received this combination of probiotic, opposite to what occurred with a similar sample size of subjects who only received the standard of treatment plus placebo, I mean non-steroidal anti-inflammatory drugs, some drugs to treat fever, etc. And at the end of the day, first of all, you can immediately notice that the most of the variables at the moment that we were looking at, some were some similar. And at the end of the day, also we evaluated what are the number of copies of Basalco that this patient has. You can observe some similar behavior in terms of the copies, the number of copies that they have. We also measure the basal level of substances such as immunoglobulin A, immunoglobulin B, and D-dimer, etc. And when we analyze this a clinical point of view, what are the behavior of this patient, first of all, you can observe that the number here of subjects who receive the combination of probiotics, they obtain a complete remission in a faster way compared with the subjects who receive the placebo. Fortunately, not either on the probiotic group nor on the placebo, we have subjects who require to be hospitalized or that they have some problem. And at the end of the day, the most important hallmark for us was secondary to different immunological and biochemical behavior. In terms of example here, the viral load, you can immediately notice that around the day 15 that adults start to receive the probiotic, they reduce significantly the viral load at the same time that the different features, the hallmarks, the radiological tests, abnormalities were significantly reduced faster on the adults who received the combination of the probiotics. At the same time, the subject who received the combination of probiotics had a better response to different immunoglobulins, such as I already mentioned to you. Here you look at the subject who received the probiotic in terms of IgM levels, in terms of IgG levels, and when we measure the behavior of CPR and D-dimer, we immediately notice that the inflammation mechanisms were significantly more controlled on the subject receiving the placebo in that way, on the probiotic in that way. When we evaluated the microbiota pattern, we don't identify any differences neither on alpha diversity nor in beta diversity, and this result is very important because we immediately notice the different mode of action that the probiotic has, and opposite to what we think some years ago that every probiotic intervention needs to do modification of the microbiota. This is not necessarily true because we have a lot of different mode of action that the probiotic has in that way. In a secondary analysis also, which was around 1.5 years, we already demonstrated how the relationship of the different carriers of interferon alpha 2A compared with the subject who received the probiotic group opposite to receive the placebo were significantly modified, and the same occurred with the interferon alpha, but also with the interferon beta in that way. Finally, when we correlated the change of the interferons and what about the tumoral activity in terms of immunoglobulin, we really notice a very strong and significantly relationship how these intervention modulators to the tumoral system and at the same time the pathway of interferon were modulated. So at the end of the day, related to the technical messages, in this moment, the importance of the microbiome in different areas of the clinical arena is very important. Not only when we talk about what microbiota, but also when we talk about respiratory mass and so on and so on. And it is important since at the lecture, all of you that all those hallmarks that we identified on the labs of the clinical evidence that we move to the clinical arena, try to counterbalance not only the clinical parameters but also the marker one, trying to explain what are the potential monofunctions. Thank you very much. In time. I'm fast.
Any question?
I understand everything or they don't understand.
Thank you very much for your answer. I was wondering if there's any combination or specific probiotics for every disease. Let's see, traditional flu. Then what should I take?
No, at the end of the day, there is no silver bullet. At the end of the day, we must put something in at least 3 or 4 different terms. In terms of dose specificity, strength specificity, frequency specificity for small group of clinical conditions. The most wrong way is to say all the probiotics help for everything. So at the end of the day, some similar that occur with inulin and fructan and short and long, etc. change. We need to start to identify what are the specificity of probiotic secondary to the different monofunctions, because meanwhile some of them are very strong to modulate the expression of solute, non-gluten, clothing, the junction. There are others that interact in a very strong manner with the dendritic cells and so on and so on. So we need to start to classify not only based on what are the taxonomic family, what are the monofunctions, and it will move to the next generation probiotics. Next generation probiotics is to classify in a specific manner what will be the mode of action and move to the clinical arena in that way.
So, as you are telling us that you have to use a specific strain talking about probiotics, what do you think about prebiotics? I mean, what's the point to use prebiotics fibers in human health? I mean, it is necessary to study more the length of the chains. What's the characteristics we need to go on?
I remember in 2002 when we started to talk about prebiotics with some papers, for example, with Omoro, and we talk about galacto-oligosaccharide, fruit-oligosaccharide, etc. Then we move to the human oligosaccharide, and now we are moving to another types of prebiotics. And in a more complex way, when we talk about not only green and not only raw, when we talk about symbiotic, I mean, what are the specific combination of one probiotic and one specific prebiotic that really produce some synergistic effect? The history just starts with and the moment that we just start to understand in a very short way. Now we are talking about probiotics. So at the end of the day, I don't have answer at this moment what are the specific combinations of pre-pro, symbiotic, or whatever. At the end of the day, what we need to do is to challenge on the different clinical situations what could be the different combinations that can help you best This is a risk-cost-effectiveness analysis.
Other question? No? Thank you very much.
Thank you very much.
The next talk, by the way, another friend with a little help from my friends. Dr. Cynthia Fernandez Lainez. She's a young researcher at the National Institute of Pediatrics. She was awarded in her PhD studies with the honorific mention at NAM, and she got the cum laude at University of Groningen. She has 38 papers published, and here you are.
You want to say the floor is yours.
So it's an honor for me to be here and talk to you about this interesting theme besides two good friends. So well, during this talk, I will talk to you about a parasite called Giardia lamblia. Some of Giardia lamblia's treating strategies to invade the immune system of the host. The enzyme adenylate, which are known now on bloody. It is one of Giardia's maintenance factors. And also how we can use some functional foods such as dietary fibers that will help us counteract this parasite. So talking about Giardia, well, Giardia lamblia is an eukaryotic flagellated, in practically parasites or vertebrates. It has a cosmopolitan distribution and it's also a conservative agent of giardiasis. So infection with Giardia lamblia is the third most common cause of diarrheal disease. Worldwide, with over 300 million annual reported cases. So clinical manifestations are very variable. There are subjects that go completely asymptomatic to those that have some symptoms like abdominal pain, nausea, vomiting, and this can also result in some days. However, it can cause bilious atrophy, enterocytosis that ultimately causes severe disruption of the epithelial barrier function, as we can see here in this section of molecular biopsy. And also here we can see some of the phosphorus attached to the intestinal surface. So besides the health problem, of mechanisms used by Giardia lamblia to interact with the human immune system is of biological and medical relevance. For example, it is known that the action of cysteine proteases that we can see here, especially from catechins, well, these catechins are secreted by the parasite and they can degrade, for example, cytokines such as IL-8 in order to not present the inflammatory response by the host. This cysteine proteases also, the catechins can disrupt the movements of the intestinal epithelium, so causing a dysfunction here, as Paul already shows. So among the several virulence factors that Giardia possess, we have the enzyme adenylate. This enzyme participates in the prostate during post-parasite interaction, and we have seen that such a molecular charge is mediated in human cells by these brain receptors called toll-like receptors So in our previous investigations, we found that GLADI can exert immunomodulatory action by activating these TLRs in a dose-dependent manner through the NF-kappa pathway. And it also interacts with the host immune system specifically to TLR2 and TLR4 using these chemical cell-reporter lines. When we exposed the dendritic cells to this GLADI, we found that pro-inflammatory cytokines are secreted by these cells in presence of these virulence factors, especially alpha-1 beta and 2 alpha, in a significant manner. So in summary, through our investigations, we have found that likewise other virulence factors, GLADI can exert immunomodulation via TLRs. So the immunomodulatory capacity of this GLADI depends strongly on the maintenance of this breathing structure, and that GLADI can exert specific responses in these infantile dendritic cells. However, this is not the only actor in the scene, because it is not entirely understood how natural products such as dietary fibers can be related by the physiological processes related to parasitosis and inflammation. But what are dietary fibers? Well, dietary fibers, as Paul already showed us, are carbohydrate polymers that can be naturally found in foods, vegetables, plants, and they are obtained by physical or chemical methods. They cannot be hydrolyzed by our human enzymes, and they represent the primary source of carbohydrates for microbiota, whose fermentation products are short-chain fatty acids. And among these fibers are gramine-antiproteins, such as those extracted from agave fruit. So agave fibers are fructose-based polymers, as we can see in this image, which have a branching structure, and this branching structure can be elongated in two different directions. To the right, you can see the type beta-226 or liver type fructan. To upwards, you can see the beta-221 proteins. And these fibers have also the characteristics that has the Cornell series of fructans that means that we have one molecule of glucose between two fructose groups. So this elongation in two different directions along with the Cornell series make these fructans having a branching structure and one of the most complex fructan structures described today. These fructans that come from agave plant are widely used in Latin America. And these fructans are very famous because of their well-known prebiotic role. We mean that these non-digestible carbohydrates can promote the growth of beneficial microorganisms in the body. And to this effect, we call it indirect effect, indirect health effect, because the effect is through the products, the short-chain fatty acids, that can improve reduce the risk of excessive weight gain and obesity. They can lower the bad cholesterol, and all of these propose the improvement of the odds for a successful aging. However, before reaching the colon, GLADs get in contact with the small intestine, where they exert what we call a direct effect by interacting with the constituents of intestinal epithelial cells such as Golgi cells and Wilson cells. So dietary fibers such as gramine-antiproteins that are extracted from agave plant are immunomodulators. We also saw this in our investigations that can attenuate interestingly for inflammatory responses by inhibiting the activation of toll-like receptors. I can show you the toll-like receptor too. The mechanism is that we propose is based on these molecular protein studies, and we see that the short-chain fructan goes directly to the binding pocket of the natural agonist of TLR2. So this link between dietary fibers, such as GLADs, and GLAD factors have been previously explored. So the objective of our work was to investigate the effects of GLAD on the intestinal immune response and the potential protective role of GLADs in different chain gates. To that aim, we work with two different mixtures of fructans extracted from agave plant, one short chain and one long chain. We also work with the recombinant gliadin, which we overexpressed in bacterial system in E. coli. So we perform a series of experiments with different cell lines. For example, in this case, we work with K2 cells, which is a cancer colorectal cell line. So we grow it within 21 days. After that, we put 1,000 milligrams per milliliter of gliadin, and then we proceed to the treatment for fluorescence microscopy with an isotropy antibody. Also, with this K2 cell line, after 21 days of incubation, this is in order to get the cell line to differentiate to reticulocyte. Then we expose cells to gliadin alone in 24 hours, or we pre-incubated the cells with the DDS, and then we added gliadin. And in this case, we measure the expression of time dimension beats, and we also measure isolate production. We also evaluated the integrity of the intestinal barrier, and we made this with the measurement of real-time transepithelial electrical resistance. So through this intestinal cell lines, again, were included 21 days, then we added gliadin and incubated in 24 hours, or in another set of experiments, we pre-incubated cells with PDX, followed by the addition of gliadin, and incubated for 6 more hours. Then we proceed to the data analysis, and also we collected supernatant for isolate production measurement. We also work with the human colorectal adenocarcinoma goblet cell line, and it was again exposed to gladiolor for a combination with the ADS within 72 hours, and then we measured genes that are related to the mucus production or the stress of the epithelial endothelium. We also made this activation inhibition aside with the TLRs using proportional cell lines. For the activation and size we incubated during 24 hours with 100 nanograms of gliadin. And for the inhibition experiments, we incubated cells with PTX and then added gliadin. And finally, we also measured in infant-like dendritic cells the production of the different cytokine profiles. If they were in presence only of gliadin, or if they were pre-incubated with the GTS and then with other gliadin. So, about the transepithelial resistance of the intestinal cells against the gliadin does not perform any change compared to the control, and this is growing concentrations of gliadin, so we can see here the resistance is homogeneous. And we also convert these to quantitative results measured in the area under the curve. We can see that there are no statistical results. When we treat with the two different DPS, we also can see that there is no difference. Also, in the microscopic level, we can see that gliadin does not change the transitions, as we can see here in this control that is culture without gliadin. We see here the salt chain protein, so it's perfectly conserved. And also, in those cells that were cultured with presence of gliadin, we see the same. However, at the molecular level, we can see that gliadin increases the expression of protein 3, and the GTX prevents this noxious effect. So I am defining one of these graphs here, the one that corresponds to the protein 3 expression. Then we can see here that gliadin provokes the decrease of this expression, but here we can see that when cells are penetrated with the GTX, this effect is counteracted. And it's very important because protein-free protein acts as a sealing component of the tight junctions that will take us to maintain strong intestinal barrier. When we incubate, and this is probably the most important of our results, when we incubate cells in presence of increasing concentrations of gliadin, we saw a significant decrease in the isolate production of 78%. And this process was importantly counteracted by GTS. So it is known already that the decrease of isolate produced by belong attributed to the cathepsins, as I mentioned in the introduction, that are secreted by the parasite. I think that this can be reported with the Giardia, the complete parasite. However, now we are finding a new mechanism that may explain also this effect. And then we hypothesize that Gladi can play a role as a molecular factor in establishing communication with enterocytes to diminish the inflammatory response. Let's say it keeps happening, nothing's happening, let me live here happy, right? To diminish the inflammatory response that is guided by ILA produced by the body. And the most strict surprising result for us is that when the cells were activated with DPS, followed by the addition of Gladi, then the production of ILA normalized. We also found that Gladi increases expression of in global cells. It is again known that when these intestinal cells are included in presence of the complete parasite, it happens, MYC2 expression increases. However, we see that only with this virulence factor, we don't need the complete parasite to get also excluded. So these levels see that Gladi is contributing to this virulence increase. And all again, you see here, when we incubate the cells with DPS, the effect is lost. When we in these rocket cells also study the expression of some genes that are related to the expression of the epithelial endoplasmic reticulum, we can see that FA1 is increased, so it's significant when we incubate the cells in the presence of Gladi, and that these again effect is counteracted by the pre-incubation of cell epithelial. FA1 looks at near expressed protein, as I already mentioned. It participates in the protein response, which is activated in conditions such as inflammatory bowel disease and other inflammatory conditions. And it contributes to the production of aberrant folding, that is not good for the system. We previously found in our investigations that this, when we incubate cells with DPS, it increases the expression of FGP1. So what we can see here is that Gladi increases its expression and the incubated DPS eventually. And about the cytokine production, we can see that after we expose cells to Gladi, IL-1 beta was increased significantly, and again, our heroes were rescued from this. We also previously knew that DPS can inhibit TLR for activation, but when we challenge cells with Gladi, we see the same phenomenon, and this dose dependent. So as conclusions, we can see that Gladi itself is not a factor that is involved in previously reported disrupting processes like at the physical level, such as local chemistry. However, we can see that Gladi is playing a role as a molecular factor, more as a molecular factor, in establishing communication with enterocytes and diminish the inflammatory response guided by IL-1. We see also that with these virulence factors such as Gladi, Giardia can create an environment and more conducive to its survival in the gastrointestinal tract by weakening the host immune response. And that the resting effects of the natural products that we work with, such as the DPS, can be valuable in drug discovery or tackling the immunosuppressant action of virulence factors such as this protein, which could avoid Giardia colonization and spreading the disease. So what are the future directions of our investigations? We still have questions that have not been resolved. What are the remaining mechanisms that underlie the observed effects? What are the remaining mechanisms that underlie the observed protection and powerful protection that we are seeing with these GPS? So students are more than welcome to help us. And finally, I would like to thank my dear friends for inviting me.
Thank you very much. Excellent talk.
Cladding modulate expression of MUC2 on goblet cells. In some sense, the modulation of MUC2 to the goblet cells is related with the viscosity and with the abundance of the mucus, because there are some diseases that are just associated with the viscosity and with the abundance of the mucus into the luminal gland.
Yes, nice question. Well, I must say that we only see it at a gene expression level, and that's why I invite my students to help me to prove it at a protein level, right? Because only see the first part of the story or the picture, so we need to corroborate this at the protein level. So then I can ask to your answer.
When he talks about that the modulation of the LR to the LR4 is a black and white phenomena, or is a dose response of modulation of the activation of the LR? Because at the end of the day, we need or not some sense of activation of the LR.
Yeah. No, it's not a black and white. No, it's a dose response that we can. So the most NTFs we have, the most inhibition of the receptor is.
Thank you. That was very interesting. If you don't mind, I want to ask one question. The experiment that you're referring to with Capital 2, do you have to adjust the media that you give these cells to these experiments? Because many of these cancer cell media have high glucose components that may affect your results.
Yeah, no, only in them. Yeah.
So Lucia, do you think if we have some drug directed to land, we can use it for dialysis?
Well, based on this, yes. You mean based on this, yes? I would recommend it as a preventive strategy. Why not? Use it for encapsulation of some drugs or some probiotics or as a scenario. Yeah, that's why part of my conclusions was that this could be used for the design of specialized molecules by the pharmaceuticals.
Thank you very much. Thank you. Well, our next speaker is the youngest friend of the group. He's Enrique Sangüesa. He is a PhD student. He comes from Chile. He studied at the UNAM, Biological Sciences. And he's beginning in our lab. He's going to talk to you about this fructans from agave and combined with probiotics. And he is doing the experiments of take these fructans as a carbohydrate source to feed the probiotics and see how the exopolysaccharides are doing immunomodulation efforts.
Thank you for the presentation. Straight matters based on ingredients agave is high in the world. 75% of agave plants come from Mexico, where they have cultural and commercial importance. This plant produces lighter fibers like inulin, fructans, and agaves. These fructans are safe to eat and make fructan milk drink.
B beta 221 and beta 226. But maybe the brain and cellular which involves in a prebiotic effect. Talking about the important vital fiber in this situation. Our world demonstrates that fructose from agave banana safe and stable fibers for health, which help the immune system and promote the growth of healthy bacteria in brains. Talking about the direct effect of agave banana fructose, our team has demonstrated that fructose from agave banana, which beta 226 can reduce the profile response and receptor. Also, we found that this fructose product by intestinal barrier from chemical stress. This fructose influence the expression of several genes that codify time junction and include relatively they elevate a general human cell response. Also, although showing bad elements that provide the structure of the immune fructose for health benefit, I didn't see it good. But also, we are talking about the supersaccharides produced from biotic bacteria. These extrapolysaccharides, or EPS, are immunomodulatory carbohydrates that from bacterial biofilm. They are not digested with vitamins, and they correlate by depending on the bacterial strain and root condition, such as pH, temperature, and carbon salt. Currently, various applications of EPS are even studies which afford and fitting the condition that enhance the health benefits. After the background of information, we elaborate the next question. Can the field of the agave fructose study differentially active or inhibit the NF-kappa-B1 pathway to TDR4 and TDR2? What are the properties like this agave fructose to probiotic and then EPS concerning immunomodulation? To answer this, we perform this method. For extraction of extrapolysaccharides from bacterial superbugs, we work with probiotic strains that we isolated from deep fish. Extraction of EPS was carried out for the state. I am showing you here. To analyze the effect on the NF-kappa-B1 pathway, we use genetically modified cells that are expressing TRRs. These cells contain a shortcut which are promoting relation that recognize that extinction factor. Polymer B, the gene encoding the enzyme C. There is a system that keeps areas that recognize the ligands or agonists that produce a downstream signaling and translate to the nucleus. Then we can register or issue this presence or seed in that secretion, production of the extracellular medium, as I am showing you here. So I am going to show you that result is still. First, I am going to show you the direct effect of agave fructose on the NF-kappa-B1 pathway. graph where in the x-axis the a negative control, we set for a linear control. After that, cell reaches PPS, that is natural linear of ideal expression. After that, I am showing you a growing concentration for each and the fructan from Astoria gas in Milan. Or also colored azul angustifolia, also Cayo de Espadín or Agave Sandiana. So as you can see here in the y-axis, you can see the full angle or activation of the pathway. Always on this experiment comparing the negative control which the experimental size. Then you can see here are the agave fructan and the Celular. Activation dose level. This activation suggests that there are synergy between several key errors. Trying this pathway, we can see here that another Samiana fructan have a stronger effect. Activating this pathway 18 times more compared to negative control. Now I am going to show you some experiment of inhibition. It means that I try to split the cell HP1. HP1 cell that express all in TLR. I freeze when the fructan and after that I include with the EPS ligand. Here we are looking for the inverted activation EPS in fructan. We also, you can see here, no all is agave. Fructan inhibit EPS induced response in the cell line. I showed you the effect on cell that express all TLRs. Now I want to show you cell that express only TLRH1. In the case, this cell line called TLR2. Our cell that express only human TLR receptor, as you can see here. We are growing concentration of fructans and in this case only agave sandiana toward activation of the muscle. And in this case, only agave sandiana toward activation of the pyruvate suggests of this agave sandiana fructan for exercise that immunomodulatory effect via TLR2, and here you see in cell line. On the other hand, we see performance inhibition spirit of TLR2 cell. We saw do not one of the fructan for external inhibition of the infection. As you can see, here nor they nor the fructan inhibit comparing its the positive control. And moreover, agave sandiana does not show inhibition but show activation. Something like synergic effect of the DPS and the fructan. When we treat the activation of DDR4 cell, we saw something interesting. These were also the kind of activation of the alpha and activation. Was observed with agave sandiana fructan is about 3 times more than negative control at the high concentration of the agave sandiana and agave lucifolia. There were 2 times more we had a growing concentration of the EPS culture, which are different carbon sources, agave tequilana, agave sarniana, and agave fusifolia. Here you can see tissue one cell at the activation or the cell line, which EPS is a different temperature and close to the gun. Across there are different structures. The activation was observed online at the Curie EPS concentration throughout the three fructose sites. And other hand, the integration experiment was only seen at the lowest concentration of the three EPS. True, the effect was also dose-dependent. They were tried by DLR, 4 cells, and this cell online increased concentration of Orion EPS from agave fusifolia and agave tequilana activate the pathway. On the other hand, inhibition of the pathway was online observed, which provided EPS to choose when agave fusifolia as carbon source. We also tested DLR, 2 cell neurostructure that are EPS, activating the pathway with the hydrate concentration of provided EPS from agave tequilana and agave sarniana, with direct effect on the other hand, inhibition for the pathway by observed which or EPS, with a stronger effect from agave sarniana, inhibition EPS from agave tequilana and agave fusifolia was dose-dependent. This result hits the importance of TDR2 receptor activation and inhibition of the pathway. After the results, we can see that there is a differential effect between various structures from around the probiotic EPS, which confirm the distant immunological properties according to the level of activation on any kappa-81 pathway via TLR2 and TLR4. This differentiation might be linked to the potential of non-biochemical to produce an inflammatory response via TLR4 for fructans and TLR2 for EPS. The last one, the high activation level shown by fructans from agave sarniana in both TLR2 and 4 represent a channel in the illustrator the potential therapeutic use and the deep contact with the inhibition for activation response. Many are TLR2 and 4 agonists. Thank you for your attention.
Thank you. Can you pass one slide? Because Enrique split one of the slides. This one is a beautiful, I think, a beautiful results, because when we incubate the cells expressing TLR4 with the fructans, the agave fructans, and after that we use the LPS, the natural ligand of TLR4, we saw a dose-dependent protection against LPS. And we knew something about the agave tequilana and chicory plant, but these are new results with agave sarniana and fusifolia. And as you can see, sarniana and fusifolia are very, very potent inhibitors of TLR4 signal. Okay, sorry. Any question?
This is quite impressive. The amount of innovation is really enormous. It's much more than what we have seen before. But I'm also quite impressed by what you saw with the EPS structures. We recently got a paper out where we could feed bacteria some galactose and human biologicals to a cell. We saw actually that the structure completely changed. So I think we have something similar. So I also planning to do analysis on the structure of these EPS molecules.
Sí, Juan está diciendo que si tienes pensado hacer estudios de estructura de los CPS porque son es muy probable que tengan diferentes estructuras.
Básicamente porque la fuente de carbono, dependiendo de la cena, de los subsecretarios van a ser como tal.
It's one of the aims of the PhD of the yeah.
I have a question. Congratulations on your work. It's really nice. Now we can see that agave is not the only one that's doing nice work. What do you think that would be the applications of your findings?
Basically, in social chronic disease in the amount of arthritis, pero estaría seria efficacemente alle intestinal level disease. Ulcerative colitis and chronic gastric disease, inflammatory disease.
Well, if not, thank you very much to all of you. It was a very good time for us, and see you later.